All right, in this chapter, we're going to learn how to solve systems of equations. We're going to examine them, what kind of solutions they have, what does it mean to have a solution to a system of equations. And we start just by looking at a single equation, linear equation in two variables. So it's linear because we don't have like x squared or square root of y or x over y or x times y. The variables appear as just a constant times a variable to the first power. A constant times a variable to the first power. And we're adding or subtracting those. And then there might be a constant term also. So that's what a linear equation in two variables looks like. The standard form of a linear equation in two variables looks like this. You have some constant times x plus some constant times y equals some other constant. And as long as a and b are not both 0, that will define a linear equation in two variables. So a linear equation in two variables, like that single equation, it doesn't have like a singular solution. It's not like when we solved a linear equation in chapter 2. There we had one variable. So when we solved it, we were able to get an answer like x equals 3 or something. But if we're looking at a linear equation in two variables, there are actually many, many points, many, many pairs of values that can make this equation true. And if you graph all of those points, you'll get a line. That's why we call these linear equations. Their graph forms a line in the plane. So if we're working with a linear equation that's in standard form, like this one, 3x minus 4y equals 12, then I think the easiest way to graph that line is usually just to find the two intercepts. Any 2 points will determine a line. So usually we pick intercepts, like where it crosses the x and y axis, because those are just easy to find. So to find an x-intercept, to find where it crosses the x-axis, we set y equal to 0. Now here we're doing this in the context of a linear equation, but this is true for any equation in two variables you might have. If you want to find an x-intercept, you set y equal to 0, and then you solve for x. So if we set y equal to 0 in that equation, our equation becomes 3x minus 4 times 0 equals 12. And of course the 4 times 0 is 0, so we get 3x equals 12. We divide by 3. And we get the value x equals 4. And that means that the point 4, 0, x is 4, y is 0, that's a point on our line. Then we can find the y-intercept. And to find a y-intercept, we set x equal to 0 and solve. And again, that's true for any equation. If you want a y-intercept, if you want to find where it crosses the y-axis, you set x equal to 0. So if we set x equal to 0 in this equation, we get 3 times 0 minus 4y equals 12. And of course 3 times 0 is 0, so we get negative 4y equals 12. If we divide both sides by negative 4, and we get y equals negative 3, and so our y-intercept is the point 0, negative 3. X is 0, y is negative 3. Now we have 2 points. And I'm going to plot those 2 points. So our x-intercept was 4, 0. And our y-intercept is 0, negative 3. And since 2 points determine a line, I'm just going to connect. I'm going to draw the line that goes through those 2 points. And of course this line extends infinitely in both directions. What this means, when we graph this, what it means is that any point, any pair of xy coordinates that will satisfy this equation here will lie on that line. And equivalently, any point on that line will satisfy. This line is a visual representation of all the points, all the xy pairs that satisfy that equation. some line, you know, we said that we had a linear equation as long as both x and y coefficients, if they weren't both 0. If one of them is 0, then you will be able to get either a horizontal or a vertical line. And if one of those is 0, you can simplify the equation as simply x equals some constant or y equals some constant. The equation x equals a constant is always going to be a vertical line. What determines that line is that the x coordinate is always the same, is always that one value. And so that will be a, you know, no matter what y is, x is the same, that's a vertical line. Likewise, if y is equal to a constant, that means that no matter what value x takes on, y takes on the same value, so that defines a horizontal line. Real quick, we can do this example here where it says sketch the lines x equals -4 and y equals 6 on the same coordinate plane. Well, x equals -4 will be this line right here. And y equals 6 will be this line right here, that horizontal line. Now, for lines kind of like the one we looked at here, right? It's not vertical, not horizontal, but there is a slant to it, right? There's this slope. So the slope of a line will tell us, kind of describes whether the line is increasing or decreasing, like whether it rises or falls as x moves from left to right, and maybe how steep it does so. And so the slope is really just a numerical description of that. So the slope of a line, say I have a line that contains 2 points, right? x1, y1, and x2, y2. The slope is given by this formula, y2 minus y1 over x2 minus x1. We can remember that as being rise over run, and here I am going to misspell the word rise on purpose. I'm trying to remember that the y's go on top. So if I want to find the slope of the line that passes through these 2 points, we can use that formula. First, I'm just going to pick which one of these points is my x1, y1, and which one is my x2, y2. It doesn't matter how you make that choice. You will get the same value in the end for the slope. So I'm going to take the first one and say that's my x1, y1. The second one is my x2, y2. I'm going to start just by writing out the formula. y2 minus y1 over x2 minus x1. That gives us 3 minus a -3 over 5 minus 2. 3 minus a -3, that's 3 plus 3, or 6. And 5 minus 2 is 3. And so we get a slope of 2. Now, when we think of slope as being a rise over run, you know, when we just state what the slope is, usually we would just say, you know, give it in its simplest form, which is 2. If we want to think about it as a rise over run, sometimes people will think of it as 2 over 1, just so we have that comparison. 2 up versus 1 over for the slope. And we're going to see how we can use that slope to help us do some graphing. First, though, we're going to examine the different possibilities for the slope. So if, when we compute that value for m, we get a positive number, as we did in the last example, that means that if I were to graph that line, the line would be rising as x moves from left to right, so the line is increasing. If the slope is negative, that means it's falling as x moves from left to right. If you get a 0 slope, that means it's a horizontal line, meaning it would just look like y equals a constant. If when you find that slope in the formula, you get, it would make you divide by 0, that means it's a vertical line. We say then that the slope is undefined because, of course, we know we cannot divide by 0. Another form, we've been looking at the standard form for the equation of a line, but another form which you may be more familiar with from what you've done in previous math courses is the slope-intercept form. So if you have an equation of a line and you solve it for y, you get y equals, and simplify, it'll take on something that looks like this. Y equals mx plus b, where m is the slope and b is the y-intercept. So that's why we call it the slope-intercept form. So these can be convenient for graphing because you basically get a point for free. If they give you y equals mx plus b, you have the y-intercept right there. Is the constant term at the end of the equation. And they give you the slope, and you can use the slope to obtain another point. So if I want to sketch a graph of the line 2/3 x minus 3, well, the y-intercept is the point 0, negative 3. I have to make sure I grab that sign. So I start by plotting that point. Now I need 2 points to determine a line, but I know the slope is 2/3, and that means that starting from any point, I can get another point on the line if I go up 2 and to the right 3. This is a positive slope, so when I obtain that other point, it should look like the line is rising as x moves from left to right. So I'm going to go up 2 and over 3 to get another point. And there's our point. Let's try another one. Here they give us an equation in standard form, 2x minus 3y equals 6. They say write this equation in slope-intercept form, then sketch a graph. So they've asked us to write it in slope-intercept form, and that means that we want to solve it for y. So we're going to do some algebra first. I'm going to solve this for y, so I'm going to subtract 2x from both sides. Negative 3y is equal to negative 2x plus 6. If you were going to write 6 minus 2x there, that's fine. They're equivalent. And then I'm going to divide both sides by negative 3. Now, if I'm dividing that entire side by negative 3, then I can split up that fraction and divide each term by negative 3. So negative 2x over negative 3 is a positive 2x over 3, and I'm going to simplify that by writing it as 2/3 times x. And then it kind of matches up with that slope-intercept form as a slope times x. And 6 over negative 3 is a negative 2, so minus 2. And we get y equals 2/3 x minus 2. As it turns out, looks like it's the same slope as the last equation. We have our y-intercept at 0, negative 2, and then our slope is 2/3, meaning up 2 over 3. So there's our y-intercept. I move up 2 and over 3 to get another point. And there's the equation of this line.